In one of the earlier videos, we have looked at the relationship which has been written down here, that is probability of A comma B equal to probability of A given B times probability of B. And so let us look at the notations. So this one is nothing but the joint probability. This one is the conditional probability. And we will see that this is referred to as the marginal probability. Okay, so we have looked at these two ideas, the joint probability as well as the conditional probability earlier. But in this video, we are going to look at these two entities in a slightly different way. Many a times, it does help us to look at the probability in those fashions. So just let me take an example. Let's take the case of an unfair coin. Okay, and that unfair coin has a probability of heads as 1/4, and the probability of it showing tails is 3/4. And the experiment that you do here is you toss this coin 2 times. Right? And you can ask probability questions such as what is the probability of getting heads in the first toss and heads in the second toss, or probability of getting heads in the first toss and tails in the second toss, and so on. And we have answered these questions earlier. So at that point of time, we knew that you could answer these probability questions in this fashion. Say, for example, you want to find out the probability of HH. Say, for example, if you want to find the probability of heads in the first toss and heads in the second toss, we know that this can be computed as the probability of heads in the first toss times probability of heads in the second toss. And this can be done because each of these tosses is independent and one does not impact the other. And so in this case, the calculation would be probability of 1/4 for heads in the first toss and 1/4 probability of heads in the second toss, and that gives us the probability of 1/16 to get heads followed by heads if we are to toss this unfair coin twice. But then let us look at this whole calculation in a slightly different way. So we are going to draw a tree diagram for the 2 coin tosses. So let's begin at some point. And then we do the first toss, and we could get heads with a probability of 1/4, or we could get tails with a probability of 3/4. And if you happen to get heads in the first toss, you could get heads in the second toss with the probability of 1/4 and tails with a probability of 3/4. And here again, for the second toss, you could get heads with a probability of 1/4 and tails with a probability of 3/4. Now here, let's say you wanted to calculate what is the probability of getting heads in the first toss and heads in the second toss. So what we have to do is, to find out this probability, we have to trace a path on this tree diagram such that we get heads followed by heads. So in this situation, we have to go this way. And in that process, you will see that we will encounter 2 probability values, and all we need to do is multiply these 2 probabilities. And so we have this calculation 1/4 times 1/4, which is 1 over 16. And we have got that already. Say for example, you have to compute the probability of TH. How do we do this? Well, we have to trace a path such that first we get T, then followed by H, meaning that we have to come to this point, and from here on we have to go to this point. And in that process, we have these two probability values, 3/4 and 1/4. So all we need to do is multiply these two probabilities. And so we have 3/4 times 1/4, that is 3 over 16. Similarly, probability of HT will be up to this point, meaning 1/4. And from here, we go over there and we have this probability value 3/4. And that is again equal to 3 over 16. And what is the probability of TT? Well, from here we go to this point and we get to have this probability value 3/4. And from here on, we go to this point and we encounter another probability value 3/4. And so this is 9 by 16. Okay, so 9 plus 3 is 12, 12 plus 3 is 15, and 15 plus 1 is 16, which means that if you add up all these probabilities, you get 16 over 16, which is equal to 1. So this is a way of looking at the joint probability. If you can draw a tree diagram, then one way to get to the joint probability calculation is to trace the appropriate path in the tree diagram and keep multiplying the probability values that you keep encountering. Okay, so now let us talk about conditional probability, which can be symbolized as P of A given B, meaning probability of A conditioned on the fact that B has also happened. And let us look at this conditional probability with an example. So we will consider a fair coin or a fair dice, let's say, meaning all the outcomes 1, 2, 3, 4, 5 and 6, they will have equal probabilities of occurring. And here we are going to ask 2 to 3 simple questions, and using these questions and trying to answer them, we will understand the idea of conditional probability. So the first question is, what is the probability of getting 2? Now that is simple. 2 is 1 out of the 6 possible outcomes, and it's a fair die. So the probability of getting 2 is 1 over 6. What if we ask, what is the probability of getting an even number? Well, that also is not difficult to answer. Even numbers are 3 out of 6 possible outcomes. So the probability of getting an even number is half. Okay. Now the third question is going to be different. And the question is, what is the probability of getting 2 given that the number you have got is even? All right. And this is basically conditional probability that we are looking for. So let's try and answer the question intuitively first. Okay. So here we have that it is given that the number is even, meaning we will now only have to concentrate on number 2, 4 and 6. So our universe has only these numbers 2, 4 and 6. And with that, what is the probability of getting 2? Now 2 is 1 out of the 3 possibilities, 2, 4 and 6, and so therefore the probability of getting 2 given that the number is even is 1/3. Now let's try and understand this thing based on what we already know. Remember, we already know the idea of the joint probability, and we can always look at this joint probability, that probability of getting 2 and the number is even. And in one of our previous videos, we have seen that this can be expressed as the product of probability that it is 2 given that the number is even times probability that the number is even. Fine. Now let's see whether we have understood the whole thing correctly by seeing whether the left hand and the right hand side of the equation match up with each other. Let's intuitively find out the answer to the question, what is the probability that the number is 2 and that the number is even? Now, if you look at all the possible outcomes, 2 is the only number that satisfies both these criteria simultaneously. That is being 2 and being even. So the left hand side, the probability is 1/6. What about the right hand side? Let's ask, what is the probability that the number will be 2 given that the number is even? And we have already computed that, and that is 1/3. So this is 1/3 times probability that the number is even, and that is equal to 1/2. And so now you can see the left hand side of the equation and the right hand side of the equation, they kind of match up. Okay, so in this point of time, it will also make sense to try and see whether you could also make some sort of a tree diagram for this kind of a situation. Well, you can say that let's see first we can look at the nature of the number. So what can happen is the number can be even first, E for even, or the number could be odd, O for odd. So the number can be even with a probability of 1/2, and the number could be odd with a probability of 1/2. Now, given that the number is even, the probability of getting 2 is 1/3. The probability of getting 4 is also 1/3. And probability of getting 6 is also 1/3. Similarly, if the number is odd, then the probability of getting 1 is 1/3. Probability of getting 3 is also 1/3, and probability of getting 5 is also 1/3. Right. So now let's compute what is the probability that the number is even and that the number is 2. Well, we have just looked at some time back that you can actually compute the joint probability by tracing the path that the number is even and that it is 2, and you can multiply the probability values that you encounter, and so that is going to be 1/2 times 1/3, that is equal to 1/6. And that's precisely what we have gotten when we had looked at the answer to this probability. Now remember, the probability of getting 2 and even number is same as probability of getting an even number and 2. So what I'm trying to say over here is that probability of A and B is same as probability of B and A. So when it comes to joint probability, it doesn't matter whether you are writing A first followed by B or B first followed by A. Now, one more thing that you must notice is that if you were to find out all the joint probabilities, meaning even and 2, even and 4, even and 6, then odd and 1, odd and 3, and odd and 5, if you compute all the joint probabilities and add them all up, you will find that it sums up to 1. So meaning you could also look at, joint probabilities, conditional probabilities in form of a tree diagram. Okay, so just to put it once again, when we say the probability of getting even and 2, we are basically tracing this path and multiplying these two probability values to get the joint probability. And when we say that given that the number is even, the probability of getting 2 is 1/3. And so this probability becomes a conditional probability.